Hello everyone, today I am going to show you a project in which you will get some idea that how a capacitor can be charged and discharge happen and what will be its responsive curve. I think if you are an undergrad student, you will also get this idea in oscilloscope, but I am showing you today in PC through Arduino Uno. And you will also get idea what is the function of a PWM pin in Arduino Uno, and you will get the responsive curve of a analog sound sensor. This is the analog sound sensor in this project. I am showing you details, so I am going to unplug this. You can see this is the analog analog and digital sound sensor. It has both. It is possible to both utilize its analog and digital output or input, but I am utilizing here in analog mode. So without further describing, I am going to my Arduino IDE, and this is the code, and you will get the whole code and description in my GitHub. So when you read the description, you will get the total idea and schematic. In brief, I am showing you that the code here. I'm going to give the code to upload my Arduino. Uploading complete. Now we can go to the serial monitor first. You see in serial monitor the button value is 0, capacitor value is 1. If I yes, capacitor value is sometimes 0 or 1, and it has some showing some sound value. If I push the button, you see the capacitor value is increasing. Now we can see it in serial plotter. Now I am going to push the button. You can see this is increasing, and if I release the button, this is discharging. So again I am push the button, the charging start, and if I release the button, the charging that discharging is happen. Now come back to the code, and I am if you read the code you can understand everything. I think, but I am showing you an interesting feature that in analog right here you can see that the value is show is 125. So this is I am using pin 9, which is a PWM pin, and I am using the value is 125. I am going to change the value. I am going to change the value to suppose 80, and I am going to upload the code again. Yes, uploading completed. Now we can go to the serial monitor first. I am push the button. In this value I think you cannot understand what is the difference, but if I show you the serial plotter, I think you can understand the difference. You see that it is also happening the charging and discharging, but in lower duty cycle. Now come to code again, and I am changing this value to maximum 255. Let's see what will happen now. I am going to upload the code again. Yes, uploading done. Now we directly open serial plotter and push the button. You can see the difference. You can see the difference. So what is the explanation? I am going to show you now. So here is a brief explanations of the capacitor charging and discharging phenomenon. We all know about the duty cycle, so I am briefly describing that when we set the value 80 PWM value, so then duty cycle is 31%. In that case, P9 effectively give voltage 1.55 volt. So we can get a gradual increase curve. But if I give the PWM value 125, we can get a slightly steeper but also smoother curve. But when we give 225 to PWM, then duty cycle is 100% and the capacitor is get 5 volt 100%ly. In that case, the curve is very steep. So this is a little explanation. Now I am going to show you the function of a analog sensor. You know, the upper curve is for the sound sensor and the below curve is for the capacitor. You know, yes, this is the for the capacitor. And you know, when you see that when I say something loudly, you see the fluctuation of the curve. To understand more clearly, I am going to create a peak sound. And you see the curve and the fluctuation. So this is the overall project, and now I am going to tell the inside of that project, that from this. So what is the inside of this project? Actually, the main theme of this project is you can understand the capacitor charge and discharge behavior. You also understand that time constants of a capacitor, that is tau is equal to RC, and its experiences. You understand that PWM's practical impact, and you also know that analog sound sensor integration and its curve visualization. So it will help you for the groundwork of mixed signal data acquisition, and it also help you for the human capacitor interactions. For example, when I push the button, the value is changing accordingly. And in future, this intuition or this knowledge will helpful for wearable electronics, biosensor, neuron firing, and capacitor like response simulation. And it also helps you for the signal analysis, waveform understanding, and response dynamics. That's it. Thank you for all.